All right, number one. So number one says to base your answer, and this is for the energy and atmosphere Regents review. And number one says base your answers to the following questions on the diagram below, which represents the greenhouse effect in which heat energy is trapped in Earth's atmosphere. Which type of radiation from Earth is the long wave radiation absorbed by greenhouse gases? So first and foremost, when they're asking for what type of radiation, right? Page 14, if you look at page 14, we get a list of the different types of radiation that exist. And so as we scroll, let me just flip this. Here we go. Here we go. All right. And so we have seven different types of radiation. We have radio waves, microwaves, infrared, visible light, ultraviolet light, X-rays, gamma rays, right? And so one of these seven, as a question says, is being, oops, is being absorbed by greenhouse gases. All right. Now, it's focusing on this type of radiation that is coming directly from the Earth, right? And what does the Earth give off? The Earth gives off heat, right? Heat is basically another word for heat that we may even think of is another word for it is infrared radiation. It's infrared radiation. And so greenhouse gases, they're absorbing infrared radiation that comes from the Earth, right? The Earth is actually giving off heat, escaping it into the atmosphere, and greenhouse gases are absorbing that infrared radiation. So the correct answer is choice one. All right, number two. Number two says, in which two temperature zones of the atmosphere does the temperature increase with increasing altitude, right? So where do I even find the temperature zones of the atmosphere, right? Where do I even find information about that? I'm looking on the reference tables. And if we look on page 14, right, if you have your reference tables open, you open to page 14 of the reference tables, right? We see temperature zones listed right here. And we have the troposphere, the stratosphere, the mesosphere, and the thermosphere. So now the question was asking, right, in which two temperature zones does the temperature increase with increasing altitude, right? So as the black line is showing me, right, with the black line, I'm able to see the altitude as well as what's happening to temperature, right? And so as the black line is going up, which two temperature zones of the atmosphere is temperature increasing? Now, when I look at temperature, I know that when the black line is moving to the right, that means that the temperature is increasing. When the black line is moving to the right, temperature is increasing as it goes up. All right. And where is the black line moving to the right as it's going up? That shows me temperature is increasing. The stratosphere is one, right? Because as the black line is going up, it started from negative 55 degrees temperature to 0 degrees temperature, right? So the temperature is going up. The other one that shows where temperature is increasing is right here, the thermosphere, right? We started at 90, right? 90, negative 90 degrees Celsius, right? And we end at over 100 degrees Celsius, right? Over 100. So that lets me know temperature was increasing here too. So the stratosphere and the thermosphere, which is choice B? Which is choice B? Number three, it says for which phase change does water absorb the most energy? All right. So first of all, we're talking about phase changes. Let's look at our notes, right? So in the energy atmosphere notes, these are the different types of phase changes that occur. All right. We have melting, evaporating or vaporizing, right? Liquid to a gas. We have freezing, liquid to a solid, condensation, and sublimation, solid to a gas, right? There is a page on the reference tables that talks about the energy, right, of that is either absorbed or released during these phase changes. What page, everybody? Page 1. And if we look at the properties of water, they tell us the amount of energy gained during a phase change, like melting, or the energy released during a phase change, for example, like freezing, and they tell us the amount. So when I'm looking at the question says, for which phase change does water absorb the most energy, not release, but absorb, right? So when I'm looking at page 1 of the reference tables, I'm only focusing on the phase changes that mention being absorbed, right? That you're collecting, you're absorbing, you're collecting energy. So not releasing. So anything that talks about releasing, we can't use that. So condensation, we can't use, and freezing, we can't use. All right. Now we want the one that absorbs or gain the most energy. And the one that has the most is vaporization. As you can see, 2,260 joules per gram. That is the most energy that's being gained and is during vaporization. And so what is the best answer? Is going to be choice 1, evaporation. Vaporization and evaporation, same thing. Number 4, if the base of a cloud is located at an altitude of 2 kilometers and the top of the cloud is located at an altitude of 8 kilometers, this cloud is located where, right? And all of these different terms that we see here, these are all temperature zones of the atmosphere. We can also think of them as different layers of the atmosphere. And so what page of the reference tables are we going to look? We're looking at page 14. All right. And so they want to know if you start at, right, the base of a cloud is starting at 2 kilometers and the top of the cloud is 8 kilometers. So then, therefore, all right, so let's look at page 2 to 8, right? Sorry, page 14, the reference tables. And so, therefore, right, we're going to look at the kilometer side. So when I'm looking, kilometers side is right here, is on the left side. And what layer of the atmosphere is between 2 to 8? So I'm going to zoom in. And how much is each line going up by? 0, 10, right? 20, 30, and 40. And the left side is the kilometer side. So 2 to 8 looks to be somewhere from here to below 10. And what layer of the atmosphere am I in, right? Between 2 to 8, it looks as though I am in the troposphere. So I'm only in the troposphere. So the correct answer is going to be choice. Hold on. Is going to be choice C. All right, number 5. Number 5 says, which type of surface would most likely be the best reflector of electromagnetic energy? All right. So when I look at my notes, right, and in my notes was saying what type of objects make good absorbers of radiation, right? Objects that are dark and rough. And what type of objects make good reflectors of radiation, right? Or electromagnetic energy. And it's objects that are light and smooth. Those are going to be the best reflectors. So when I look, it's going to be objects that are lightly colored and smooth, which is going to be choice C, right? The best reflector of electromagnetic energy is also the same as the best reflector of radiation. So light and slightly colored and smooth. Number 6, ozone gas in the Earth's atmosphere helps to protect life on Earth. This protection is due to the ability of ozone to absorb what? So when I look at my notes, right? And so I'm looking at the ozone layer, right? How does the ozone layer affect insulation? Well, the ozone absorbs what? Ultraviolet waves. Ultraviolet waves. All right. It absorbs ultraviolet waves from the sun and protects the earth from harmful solar radiation. So that's something that we just have to know that the ozone is a gas, right? The ozone is a gas, and this gas absorbs ultraviolet radiation, which is choice B. All right, number 7. Number 7 says the graph below shows the average changes in monthly global air temperatures from 1990 to 1992. The time of a major volcano eruption of Mount Pinatubo in the Philippines is shown. Explain how this volcanic eruption could have caused the general decrease in temperature shown by the graph. All right, so we have a volcano, right? And when a volcano erupts, right, we know besides lava, right, what else is being released from the volcano, right? We get ash clouds, right? And what's important about ash clouds is that these clouds have a ability to reflect, right, insulation. So if this is the ground, right, if this is the ground, if this is the Earth's surface, and a volcano has erupted and giving ash clouds, right? These thick ash clouds can prevent sun rays from reaching the Earth's surface, right? So you're only getting a few, if that's actually passing through, right? Most of the ash clouds is actually preventing sun rays from hitting the Earth's surface. And so what does that mean? If you're not getting as much insulation hitting the ground, your temperatures are going to decrease, right? Anytime that a volcano erupts, the ash clouds that gets released into the sky, it actually decreases what we call the atmospheric transparency, right? Which means that there's more things in the atmosphere that's not allowing for insulation to reach the surface of the earth. And the less insulation that's reaching the surface of the earth, that means the cooler the temperatures are going to be. So in your answer, you could have said any one of these options here. Oh, let me make sure that I zoom, focusing just on 7. All right, focusing just on 7. So if you said dust from the volcanic eruption carried high in the atmosphere reflected and reduced the sunlight reaching Earth's surface, that is fine. right? If you mention anything about what I just described, about what has taken place, that's fine too. If you said the eruption caused a decrease in atmospheric transparency, that is fine. If you said ash blocks insolation, or if you said ash is blocking sun rays from reaching the Earth's surface, that also would be fine as well too as an answer for number 7. You are free to pause the video to rewind so that way you can check to see if your answers are correct. Basic answers to the following question are your knowledge of earth science and on the diagram below. The diagram shows the apparatus used as a model to study large-scale motions within the Earth's atmosphere. The water was heated for several minutes. What type of energy transfer is indicated by the arrows in the diagram? All right. So we know that this is a fluid. This is a fluid, and it's showing the circulation of heat within the fluid right here, right? In the middle, you have the more fluids, right, that are rising up towards the center. And we have the cooler fluids that is spreading outwards and sinking. And so this circulation of heat is taking place, right, within a fluid. And when we look at the circulation of heat that is taking place, when we look at our notes, the circulation of heat in the atmosphere of fluid due to its differences in density, that relies on what convection is. And so the correct answer is going to be choice 1A. So number nine says state one greenhouse gas that is an excellent absorber of infrared radiation and may be responsible for global warming. I do just want to emphasize, right? It says state one. So sometimes students have a tendency of writing more than one answer because sometimes, they feel as though, hey, the more that I write, the greater the chances of points that I'll get. In this case, what we don't want to do is write one correct answer and then one incorrect answer, right? So a greenhouse gas, as the problem says, is an absorber of infrared radiation, right? And it's also possibly responsible for global warming. The more greenhouse gases that we have, the more infrared radiation that it's absorbing and re-radiating back into the atmosphere. So when I look at our notes about greenhouse gases, right, is a gas that absorbs terrestrial, right, or infrared radiation. And so carbon dioxide is a greenhouse gas. Methane is a greenhouse gas. Water vapor is a greenhouse gas. So if you mention any of those three is fine, all right? The Regents also, if you wanted to include ozone, O3, that is acceptable, and CFCs. All right. That is fine as well too. All right. But the main ones that we focus on in this class, right? Water vapor, methane, carbon dioxide. All right. If you wanted to say nitrous oxide as well too, that's perfectly fine. Ozone, as we said, that's fine. And CFCs. So number 10 says basic answers to the following questions on the passage and diagram below and on your knowledge of earth science. The diagram represents a house located in New York. And so it says solar collectors and solar heating systems harness the power of the sun to provide thermal energy for heating hot water and house interiors. There are several types of solar heating systems. The best system will depend on the geographic location and the intensity of the sun. A solar heating system saves energy, reduces, let me make sure I highlight, saves energy, reduces utility costs, and produces clean energy. The efficiency and reliability of solar heating systems have increased dramatically in recent years. So the question says, state one advantage of using solar energy instead of burning fossil fuels to produce thermal energy for your home. The the article, the passage, the paragraph, it tells you already the advantage of using solar energy instead of burning fossil fuels. All right? It tells you, where does it say it? Right here. A solar heating system saves energy. So if you said it saves energy, that's fine. If you said it reduces utility costs, that's fine. If you said it produces clean energy, that is fine. All right. These are some of the other ones that you could have added as well, besides the one that was mentioned in the reading. You could have mentioned that a renewable source of energy has less effect on the environment. You could have said less pollution, CO2 emissions, reduced carbon footprints, less global warming. You could have said conserving fossil fuels, and you could have also said solar energy is renewable. So any one of these explanations are fine. The top three is what was mentioned directly in the reading. So when you have these types of questions, please make sure we're actually reading the questions before we are just skipping to the answer, especially because this is a short answer. And sometimes you'll have students that are just afraid or don't want to complete short answer questions. All right. It's in the reading. Number 11, it says base your answers to the following questions on the graph and map below and on your knowledge of earth science. The average monthly temperatures for Eureka, California, and Omaha, Nebraska are plotted on the graph. The map indicates the locations of these two cities. Explain why Omaha, which is farther inland, has a greater variation of temperatures throughout the year than Eureka, which is closer to the ocean. All right. So when you take a look, you'll actually see, oops, sorry. What is the difference between Omaha and Eureka? Well, Omaha is located right in the middle of the country. Eureka is located near a large body of water. And they say why Omaha, which is further inland, has a greater variation of temperatures, right? And when we look at Omaha, right, the range of temperatures is great, right? We see during the months of the summer, the temperatures are very high. During the month of the winters, the temperatures get very low. And when we look compared to Eureka, right, the temperatures don't change as much. Why is that? Well, because Eureka is near a large body of water, right? What do we know? What do we know about living by a large body of water? We know that your temperatures do not change as much, right? Because water has a higher specific heat than land. Let me type this out. Here we go. Let me type it out. Right? Water has a higher specific heat than land. That means that it takes a lot more energy to change for water to change its temperature compared to land, right? And so that's why if you're at an area that is closer to a large body of water, your temperature range is going to be smaller than if you lived more inland, far from a large body of water. And here's some other answers that you could have included in your responses to make it correct. All right. And we just focusing on number 11. So I want to zoom in. If you said that Omaha is surrounded by land which has a low specific heat, right? That's fine, right? Because they wanted to focus on Omaha. If you said the Pacific Ocean moderates the temperature climate of Eureka, that's fine. If you said large bodies of water change temperature more slowly than land does, which I was mentioning before, that's fine. If you said water has a higher specific heat than land, that is perfectly fine as well too. If you said the relative drier air, sorry, the relative dry air around Omaha has a lower specific heat than the moist air around Eureka. That is fine too. And just once again, you seeing the word specific heat, specific heat, specific heat. Remember, specific heat is talking outright. It's talking about the tendency or the ability for a substance or material to change its temperature, right? And so we're focusing on how easy it is, right? How easy it is for an object to change its temperature, to warm up or cool down. If it warms up or cools down very fast, it has low specific heat. If it takes a long time to warm up, or it needs a lot of energy to warm up or cool down, right? Then that means that it's a high specific heat. That's why boiling water, if you want to warm up water real fast, you turn the heating function on your stove, you put it all the way up. So that way you're going to try heating up as much as possible. And even then, it'll still take a long time because water has a high specific heat. And just to show you, if we can go right here on page 1 of the reference tables, which material and the value of the specific heat, right? Water has the highest specific heat, which means it's going to take the longest to heat up and cool down. Lead has the lowest specific heat, which means that it'll heat up very quickly and cool down very quickly. Number 12, basic answer the following questions on the passage below and on your knowledge of earth science, right? And the paragraph is the title is saying watching the glaciers go, right? And you can read it on your own, but just to summarize, they're basically just talking about the effects that global warming is having on mountain glaciers and ice caps. And the reading even focuses on there was a scientist, sorry, yeah, a geologist that has been studying mountain glaciers and ice caps and has been noticing that even some of the glaciers that he would see before 20 some years later is not there, right? Or it's retreated far into the distance. So the question is saying, right? Describe one action humans could take to reduce the global warming that is melting the Kelskaya ice cap. All right. And so we know, for example, burning fossil fuels, right? Burning fossil fuels could be an action that is increasing global warming, right? So one action humans can do, reduce the burning of fossil fuels. All right. If you look at here, these are some other answers that you could have said. Stop burning fossil fuels. Reduce the burning of tropical rainforests. Reduce greenhouse gas emissions, right? Because we know that greenhouse gases are playing a major role, right, in the melting, in the global warming aspect, right? Use more alternative energy sources such as solar collectors and wind turbines. So each of these responses would be fine, all right? If you wanted to say, humans could limit the creation, right? Limit the services creation of greenhouse gases, right? You could say that as well too. And that's it for this unit. Please make sure to like, like, share, and subscribe. And have a wonderful, blessed day, everybody. And I will see you guys soon. Take care.